We are live with the marquee of the summit, the man himself, Usman Asim from Avalabs. I'm going to give him a killer intro here. Uh, Usman is a senior developer relations engineer at Avalabs. He is a cracked developer, starting his career working for a variety of different projects that were looking to provide transparency into traditional sectors that lacked them, like 501c3s, and then found himself working at a leading blockchain infrastructure company called Chainstack, who is going to talk tomorrow. There, he was able to gain an eagle-eye view of the entire industry and gain some high-level knowledge about everything in the industry from a developer relations perspective. Then he found himself leading blockchain, like the Avalanche side of Chainstack, and then went to Avalabs to work further on the platform. So I'd like to welcome the man to the show. Thank you for your time, Usman.
Thank you for having me. It's a pleasure to kind of be here and be a part of this community hosted um, event, right? Because at the end of the day, we're really here to propagate the community. And at the end of the day, my job is developer relations, right? And being able to relate with the developers on Avalanche, the people who are really building on top of the platform, who may be interested on building on top of the platform, right? Nothing beats it. So really excited to be here, and kudos to you guys for really killing it with the summit.
Amen. Well, yeah, the intent here was to serve people who were not going to be able to make the main summit in Barcelona, and then build up a ton of hype for it for those who were like, kind of on both sides of the fence. And I think what we've discovered in the process is that there's so much content to discuss around subnets that I think we'll just spin this out as like a subnet channel just to go over all this stuff. I mean, there's so much stuff. Even if you study it, all day, there's new things going on. Like, just the Spruce Evergreen subnet, the permission. Basically, it's like a replacement for IBM Hyperledger, R3 Corda, all of the permissioned like nonsense, like the trail of dead in that ecosystem. I'm so glad to see that, like, and all of the institutional partners on that. So you could do, a week of content just on that particular project alone.
Yeah.
So
No, I completely agree with you. And just since you brought it up, right? I had a good time back at Chainstack, really diving into all the different types of blockchains that were out there, right? Whether it be public layer 1, layer 2 type of blockchain blockchains that were out publicly available. Well, and also the private enterprise grade blockchains, right? Like you mentioned, Hyperledger fabrics of the world, the R3 Cordas, the Quorums, right?
yeah,
Let me tell you, no one's using them.
no one's using them. They're yeah, dude, they're ghosts.
But the interest is there, right?
Of course.
The enterprises want to use blockchain for their own specific purposes, and now they finally have the ability to do so in an environment that suits them, right?
Yep. And this was what Goon was hammering since 2018. You can go back and listen to these early interviews. I remember listening to them at the time, and he was like, if you want a purple subnet, whatever that means to you, that's what you can do. You make it purple.
No, 100%. It's a developer sandbox at the end of the day, right? I know a lot of these different rollups that have been coming out recently are really interesting. Some of the different virtual machines that people have been able to launch, right? Fuel is one, for example, that I'm really a huge fan of.
I don't even know what that is.
Yeah, it's interesting stuff. Modular blockchains. It's all another rabbit hole to fall down inside of. But the interesting thing is that you could launch that exact virtual machine on Avalanche as a subnet and probably be more efficient, right? And scale Ethereum.
Yeah, and that's the red pill there. So I spoke with Stephen Gates from GoGoPool, and we sort of red pilled on that, which is like there's more Bitcoin being processed on Avalanche than there is on Lightning Network, right? And that's the red pill.
Yeah, exactly. And again, that's what we talked about at the beginning when you mentioned Spruce. People are actually find real use cases on Avalanche, right? Where sometimes at the end of the day, you and I being proponents of this industry, we tend to find ourselves in this echo chamber where all the use cases that we really believe are possible are only via the people who are actually using the technology today, right? And what's being proven on Avalanche is that there's a wide variety of use cases outside of the traditional stuff that we've seen, and that outside entities actually want to be able to develop on top of it. And so it's exciting, right? And it's exactly what this tech was meant for.
Yep. Right on, man. So you're going to take us through a deep dive of the general stack.
Yeah. So I wanted to
Great.
kind of break things down from first principles, right? I think there's a lot of conflation about what Avalanche really is within the broader ecosystem of Web3. A lot of people still like to think that Avalanche is a fourth of Go Ethereum, right? And I think that's the farthest from the truth. So it's nice to sometimes break things down from first principles and get everyone reintroduced to the platform that some of us are very familiar with.
Yeah, this will be great because sometimes like friends who are at large companies like DM me and they're like, "Hey man, can you explain like why Avalanche versus an L2?" And I'm like, "Yeah, but here's Goon talking about it." So like now I'll just be able to just give this link and like here you go.
Yeah, well, I appreciate it. I hope I can live up to the standard of being able to rep the main one. But hey, I'm looking forward to getting it kicked off, man.
All right, man, let's kick it.
All right, so to kind of start at real base principles, we're going to talk about a little bit about just consensus in general, right?
Yes.
And what consensus means for
Here we go.
for blockchains, right? So in the most basic sense, consensus is just getting a group of computers to agree on a specific task, right? And again, and the goal with these is that to get these computers to reach agreement on this specific task is a very hard and long fought problem that computer scientists have been dealing for, tens of 20 years, right? And so what the task that's being accomplished within a blockchain is being able to prove that certain transactions are correct, making sure that the ledger is being updated. Right at the end of the day, blockchain is just a ledger. And so we like to call these things distributed systems. And getting all of these computers within these distributed systems to agree is something that's been tried for many years, right? So classical consensus was introduced, it's been a part of computer science since its inception. Some of the most well-known classical consensus algorithms include like Paxos, right, which was introduced in like the 1980s. So that tells you how far things really go back. But what classical consensus really introduced was this idea of synchronous communication, right? Where now you have all these different participants within a single network being able to communicate with each other in a synchronous manner, meaning that they can all communicate together and come to one decision that is of the broader network, right?
Yeah, so this is all to all, right?
All to all, exactly.
Okay. So all nodes participating with each other at the same time.
Which was revolutionary at the time, right? And but as is with any first first iteration of software, there were some drawbacks. So initially, scalability with classical consensus algorithms was a pretty big issue, right? They typically require large amounts of communication overhead. We just discussed it was node to node. Every node had to communicate with every node, which essentially limits the scalability in a larger network, right? So this also could lead to centralization because of having smaller amounts of nodes. There are certain leaders within that network which can kind of overtake the entire network if they so choose, and not really have that distributed consensus that we all love in our decentralized systems. So that's classical consensus, right? And I still haven't started the slide deck yet, but I'm just kind of giving everyone a little bit of a brief intro into consensus before we break down what the real meat and potatoes of Avalanche can provide you. So with any pieces of technology and science, there was a new iteration. So we had Nakamoto consensus, which was introduced, which leveraged proof of work, consensus algorithm, which we're all familiar with, right? And this allowed for a lot of the issues that were present within classical consensus to be kind of addressed. So that idea of centralization was now able to be addressed with Nakamoto consensus allowing for decentralization, because now you can have an unlimited number of nodes within a network that don't require certain permissions to join that network. There's also something that was introduced called incentive-driven security. So there's certain incentive mechanisms where miners are rewarded, right? They are solving cryptographic puzzles to be able to make sure the network is secure. This is all possible by proof of work, and it also solved one really key thing that was really a big problem with classical consensus mechanisms, which was Sybil resistance, right? So classical consensus mechanisms are really susceptible to attacks, right, or Sybil attacks, where attackers can create lots of different fake nodes within a different network and then kind of overtake it. Well, with proof of work, Sybil attacks are really expensive and impractical, so overtaking 51% of the network is really tough. But again, with any piece of technology, any iteration, it had its drawbacks as well. So one of the most famous critiques of Nakamoto consensus and just proof of work in general is that it's very energy intensive, and it requires very large amounts of computational resources and compute power to be able to operate networks at scale. And so when these networks do eventually reach scale, it just becomes impractical to be able to run Nakamoto consensus for any large distributed system. And this is really where the fun kicks in, right? Because what's been a constant theme of this conversation so far is that technology iterates upon itself, right? Technology changes and it gets better, right? And it addresses certain problems that previous technology has had, and it becomes, better for people to use. So to showcase that, and just making sure you can see my screen here. Yeah. So that's where Avalanche consensus comes in, right? So Avalanche consensus was a novel consensus algorithm introduced by a team called Team Rocket in 2018, and it essentially combines the best features of both classical consensus and Nakamoto consensus, while iterating and improving upon it to be able to achieve high throughput, fast finality, and energy efficiency and security, right? And so the way that it works, without delving too deep into the low level side of it, there's something called random subsampling, which essentially allows nodes to be able to query a random subset of other nodes within the network to be able to decide whether to accept or reject that specific transaction or task that it was given. And so what that allows for is the fastest and quickest time to finality within the industry among other layer ones. So that metric is measured as time to finality, right? And so that means that Avalanche can be able to, from the minute you sign a transaction to the minute it's propagated to the actual blockchain, it's less than 1 second. And that is because of this consensus algorithm.
Right. And that's that. I'm going to hammer that because they've been like Ava Labs has been hammering that narrative for years, right? And early on, like our team at Landslide identified like other pieces of the puzzle that were suffering from finality problems. So like, and that's basically Tendermint, right? So that's why we saw that, and that's why we've like done all this work specifically to take and offer value to Cosmos and to offer value to the VM there. As an alternative to the bottleneck of Tendermint.
And it's really powerful what you guys are essentially doing, right? For one thing, you're able to expose all the different developers on Cosmos to a new consensus mechanism that they never had access to before, right? One where they might not be used to transactions propagating with under a second, right? And that's going to open the doors to a whole new range of developer innovation. And so there's been a lot of other iterations of consensus. You mentioned Tendermint, but this has been the iteration that has allowed for not only maintaining scalability, speed, but also security in the process as well, right? And so until now, this has been the gold standard of what a really high performing, scalable, secure consensus algorithm looks like. And so just to discuss a little bit about it a bit more, right? In terms of the speed, sub-second immutable finality, right? There's not really much more to say there besides saying that transactions are propagated to the network and confirmed and irreversible faster than any other blockchain out there today, right? That is a significant like improvement over probabilistic finality that was introduced with Nakamoto initially. Then in terms of different scalability aspects, right? It can theoretically power thousands of different transactions per second. That's possible by the ability of different virtual machines, which we'll definitely get into later. And then obviously this also allows for the idea of infinitely scalable validators. So unlike Nakamoto consensus, Avalanche nodes don't rely on any computational intensive or expensive consensus algorithm. This makes it a little bit more environmentally friendly, a little bit more cost effective, and it allows for people to participate in the network in a much more easier way versus having to spin up all this expensive and computational intensive hardware. And then last but not least, this is quite one of the most important things in regards to a consensus algorithm is the idea of security, right? So there's something called adaptive security, which is present within the Avalanche consensus mechanism, where the security of the network kind of adjusts depending on how many bad or Byzantine nodes there are within the network. So this makes the network a little bit more resilient to attacks. It's adjusting based on how many malicious actors it feels is within the network, and because of the random subsampling technique, these nodes are be able to be pinged very, very efficiently to be able to determine who's malicious and who's not. So that's Avalanche consensus in a nutshell, right? Just to kind of give the highest level overview I could without delving into the infinite rabbit holes that are present within Avalanche consensus within itself. But this kind of leads me to my next point, which is what lies on top of the Avalanche consensus mechanism. So we've now understood that Avalanche is moving the field of blockchain further, right? Or Ava Labs, Team Rocket, they propagated Avalanche consensus, which introduced all these new primitives that had not been seen before within consensus. And what was chosen to build on top of that was this, where there are three main essential building blocks on top of Avalanche, right? That you have to really consider when you're thinking on top of the consensus mechanism. You can think of the primary network. This essentially acts as the backbone of the Avalanche ecosystem. There's a lot of main functionalities that people tend to, get out of the primary network. This is where subnets are connected. This is where validators are created. This is where bridging takes place. This is where the entirety of the network is, the security lies. Then, one step underneath that, you have the subnets, which are the actual individual networks that are present within the Avalanche ecosystem, because within Avalanche, you can launch your own blockchain network. In addition to the primary network that is already there. And then all these subnets have their own unique set of validators with their own unique set of rules. Again, we mentioned this earlier in the beginning of the conversation. These subnets can be public, private, permissionless, whatever the case is. And these are independently operated from the primary network while still validating the primary network. So these subnets are still an extension of the Avalanche network as a whole, but tend to operate in their own ecosystems and can be connected if they so choose, which we'll dive into a little bit further later. And then there's virtual machines, right? And so then these are the runtime environments that these blockchains actually get to execute upon. And so, the cool thing about a subnet is that it can host multiple virtual machines, right? At the end of or multiple blockchains with multiple different virtual machines. So, take the Avalanche primary network, for example, which we will, break down a little bit further, but having three different succinct, blockchains within the primary network in itself is a showcase to what you could really do here with the subnet and the different virtual machines that you have. So,
right. So the primary network is made up of which three chains?
Yeah. So we're right here. We're going to jump into that right away. So the primary network is composed of these three main blockchains, right? And I wish I had for some reason my visuals weren't working. So every time I'd copy and paste a picture into Google Slides, it would show up with like one of the triangles with an exclamation point. So I was kind of peeved off about that earlier because there were some really cool graphics that are out there that allow this to be visualized in a much better way. And maybe I'll be able to bring them up after I finish the presentation. But to give you a quick explanation, Avalanche has three main blockchains, right, that are housed within the heart of the primary network. Each one of these blockchains powers a specific use case that is, specific to what a blockchain needs to be able to run at scale. So we have the exchange chain, or the X chain, which basically handles all the digital assets within the chain, the bridging of different assets from different ecosystems. It runs an instance of the Avalanche virtual machine, right? And that's very important to remember, that it's running the AVM, because you have the ability to run another custom virtual machine on a custom blockchain within a subnet. And so just wanted to really hammer that point in there, that the Avalanche primary network is a subnet itself. And so next blockchain that we have present within the primary network is the P chain, which essentially handles all the validator level operations on the blockchain. It's kind of used for creating new blockchains and subnets. And it's really the backbone of the Avalanche network, where a lot of the security, is taking place because of the P chain. And so this is running in a sense of the platform virtual machine. And then finally, we have the C chain, right, and the contract chain. This is the one that most developers are familiar with. This is the one that most users of the Avalanche platform are familiar with, because it's the one they tend to interact with the most. And the reason for that is because, again, the power of Avalanche and the power of blockchain in general is that you could really use distributed ledger technology for whatever you really choose, right? And so with Ethereum, we were introduced the idea of programmability with the EVM, and developers really flocked to the idea of creating smart contracts on top of Ethereum, and the really cool application level logic that they could write now on top of blockchains. So when creating the Avalanche primary network, a really cool concept was, why isn't there an instance of the Ethereum virtual machine created where developers could easily write the same smart contracts they're writing on Ethereum, and leverage that, while now being able to use that on top of Avalanche's novel consensus mechanism and scalable platform architecture. And so the seed chain was really just one implementation of a smart contract virtual machine that could be implemented on Avalanche, right? There's many different smart contract Turing complete virtual machines that are out there, that could also be launched as their own, subnet, or to be able to power their own smart contract implementation. So again, really hammering in the point that even at the primary network level layer, the decisions made to create the network in this way were done because Avalanche at its base layer is so open, and it allows developers on top of that to build in any sort of which way they want. And so going back here to the previous slide, where I was kind of just discussing the three main building blocks of Avalanche, all three of these go together. They're all, pieces within each other. And so the primary network being the backbone, the main place where developers get to interact with. And then very soon, as we are starting to see that, like, how we discussed in the beginning of this conversation, more and more subnets being spun out, now we're going to have individual networks that are going to start to see their own network traffic, their own, and we're already seeing with different subnets like DeFi kingdoms and prior subnet implementations as well. So it's really cool to kind of see developers now actually taking the Avalanche network architecture and building on top of it. To break down, okay, so let's see here. Okay, nice. So I did have one picture come through, so that's nice. So you can kind of see here a little visualization of the Avalanche primary network. Each one of these circles represents, you could imagine a validator slash node. And then all of these subnets are all interconnected with, different validators being present within different subnets, validating multiple subnets, validating their own subnet, and all validating the primary network at the same time. So the cool, everyone nowadays is so when we started this conversation, we discussed how technology iterates, right? And we discussed how the technology eventually improves upon itself, and the best technology at the end wins out. And and then there's more implementations made later on as more advancements are made. When Ethereum iterated upon Bitcoin by introducing this idea of programmability, it really changed the game of what people thought was possible with blockchain, and it really introduced this new primitive that had really not been explored before with smart contracts. But with it came a lot of issues, right? We discussed scalability, we discussed network throughput, we discussed limited block space, right? High fees for users when they're using blockchains when it's really high traffic. And now you have we're in a period where you have all these different people who are trying to create that next iteration and really solve for the scalability issue with Ethereum, right? Whether that's creating multiple layer 2s that will lead to layer 3s and layer 4s on top of Ethereum, or they are building a modular blockchain stack by separating data availability and the whole and a couple other things. So there's no shortage of solutions being built to solve the problems that are there with Ethereum currently today. But the subnet theory and the subnet approach is the approach that was taken from a scalability perspective, right? So not only, like we mentioned a couple slides ago, that our subnet's scalable, but they also open the door to the unlimited customization for a blockchain that you're offered. So it's really scalable architecture. It's really flexible. When you can look at a blockchain and look at the validator set, look at the runtime, and look at the full permissionless capabilities of that network, and define that on top of the fastest consensus mechanism out today, it's really powerful to put that into the hands of developers. And not force them to create these blockchains from scratch, right? So there's a lot of different, benefits to the current network architecture. And, it powers a couple different use cases. This is kind of something that's been quoted as modular architecture, but modular is kind of a buzzword right now that a lot of people are throwing around, so I don't like to use it as much, but it is something that people have called the Avalanche architecture with subnets as modular. And so here's where the real fun begins, right? And this is kind of where we are today. And this is kind of up till now has been a real primer. If you're within the Avalanche ecosystem, if you know the tech, this was all old news for you, just a refresher. But now here's where the real development lies in today. So if you've been following Ava Labs for a while, if you've been following Avalanche for a while, you've noticed that within the past year, you notice 2022 was a lot of infrastructure being built, right? You notice things like Elastic Subnets came into development, AWM coming into development. A lot of different pieces of key technology were being built within 2022. And now you're starting to really see that open architecture that was described within this conversation really coming into play by developers building on top of it, and institution, enterprises, companies, the whole 9 yards, starting to actually implement the technology into their business models. So you're starting to see development happen on two different sides here. One of the coolest developments that we started to explore now is this idea of custom virtual machines. And what that means is, like we mentioned when we were describing the Avalanche primary network architecture, the C chain in itself was just one implementation of one virtual machine that is present within a blockchain ecosystem of infinitely possible virtual machines, right? So today, a developer on Avalanche can go ahead and port over any Turing complete smart contract level blockchain, virtual machine, and create it as an Avalanche subnet. The folks over at Landslide who are hosting the subnet, they're trying to do that with Cosmos ecosystem and port it over with IBC. There's another team that's porting over the Move virtual machine and building a Move layer 1 on Avalanche as a subnet. Right, so there's some really, really cool primitives being built on the open-ended layer 1 slash Turing complete virtual machine side of things here. But then,
shout out to the Move team. I'm gonna put a link here.
yeah, the great guys, amazing use case, and just really showcasing network architecture, same as Landslide, right, and same as any other team building a custom virtual machine, because it's a new primitive that you really can't do anywhere else, and you're able to do it here, right, and leverage everything else that comes with building on Avalanche. So it's really powerful, but at the end of the day, not everyone is two buckets. At the end of the day, not everyone is a low level enough dev to build a virtual machine, right? At the end of the day, I just want to build applications, right? As a developer, that's one bucket. And then B, there's only so much smart contract capability or smart contract, Turing virtual machines out there that could be created. You could port them all over, but at a certain point, it's really creating smart contracts on top of them. What was introduced with this new tool called the Hyper SDK is the ability to build custom blockchain virtual machines that are use case specific. So the Hyper SDK specific is still alpha software, just to make that clear, but it allows developers to have a set of tools, libraries, and interfaces for building virtual machines that are geared towards very, very specific use cases, that are hyper optimized for like super large amounts of throughput, super fast transaction speeds, and essentially like high amounts of volume. So this really powerful SDK is essentially meant to make blockchains that are really efficient, really computationally efficient, and they can essentially handle high amounts of throughput. That opens the door for a lot of new development to be building within the ecosystem, because now as a developer, right, I myself was kind of brainstorming on different things I could be building with the Hyper SDK, where now instead of doing certain things that I normally would do as a smart contract on the EVM or Move VM, if I were to build on there, I could now embed that same logic at the virtual machine layer of my blockchain. And what that does is it now allows me to obfuscate a lot of things, like, allows me to maybe even go from low fees to no fees, right? It allows me to be able to allow my blockchain from, instead of having 15 transactions per second, to potentially tens of thousands of transactions per second, right? There's been certain, virtual machines that have been built with the Hyper SDK that have been running 20 to 30K plus transactions per second locally on that developer's machine who built that virtual machine. So it's a very exciting piece of technology that's being built here. It's still in development. We're still yet to see developers who have really taken the Hyper SDK to what it's possible with. I would recommend that if you're a developer who's interested in building with the Hyper SDK or building a custom virtual machine, hit me up, right, to give you guys some alpha here on this call. This is something that is just pretty internal. It's something that we're reaching out to a few teams about, but there is a lot of incentive programs that we're building out for virtual machine developers, and there's a couple programs that the DevRel team is pioneering that we're really looking forward to seeing different developers build out cool virtual machines, and we have different ways of incentivizing them, and opening up cool use cases to be built on Avalanche. So if you're a developer interested in building with the Hyper SDK or just building a custom virtual machine in general, hit me up. There's some really cool primitives to be explored here. But yeah, that's something that is instrumental and going to be instrumental going forward to really showcasing Avalanche's network architecture. Again, Avalanche is a blockchain where Avalanche is a network of networks, right? A blockchain network where you could launch multiple blockchain networks. So the idea of being able to port over a Cosmos ecosystem, level virtual machine, or a Move virtual machine, or the Solana virtual machine, or building the token VM, right, which is use case specific, is within a developer's reach. So it's really developers' playground to utilize blockchain in any way they please, and that's why like you mentioned, major enterprises are looking, and institutions are looking to utilize this technology, because now they really realize they can define the logic of what they want to build, whether it's at the virtual machine layer or at the validator layer, and build in the way that they want to, in the compliance that they need. So I'm sure we'll delve into that later towards the end of the talk, but just a quick piece there.
Right on.
And then last but not least, and I really didn't want this presentation to be just me rambling the whole time, but there's just this few pieces, but this is the last one, and it's Avalanche Warp messaging, right? And this is something that is especially prudent to this call because, as Nathan mentioned, they're building IBC connectivity to Avalanche, right? And so this is Avalanche's implementation of cross-chain, message sending. So now different subnets within the ecosystem, the primary network, will all be able to communicate with each other. So within a lot of different app chain solutions, right? A lot of different blockchains in general, whether it be at the layer 2 level, whether it be at the layer 1 level, they tend to operate in siloed ecosystems, right? Where a lot of their transactional history, a lot of the assets that are present with those ecosystems tend to stay within their ecosystems. And so with the network architecture that Avalanche is creating, of having a network of networks where you can have multiple different blockchains that all completely run and operate in different ways, some may be private, some may be permissionless. It would be a shame if these blockchains couldn't communicate with each other, right? And so that's where Avalanche Warp messaging comes in. It was introduced in BAM 5, which I mentioned a little bit earlier, came out towards the end of last year. Another piece of infrastructure that was built to kind of propagate what a lot of the movement that you're seeing this year within the actual partnership side of things. But essentially, AWM enables the fast and reliable native communication between subnets. It is powered by something called a BLS multi-signature, which essentially proves that a transaction was sent between two different subnets, whether they be of the same virtual machine or whether they be of different virtual machines. And there's the potential of multi signatures. You can be able to send multi assets, and this essentially allows for the free swapping, trading, movement of assets across different blockchains, right? And you can really imagine the power of what that can really showcase, even just in today's environment in the Avalanche ecosystem, much less from when it's really fully developed. So games being able to share assets, major institutions being able to transfer assets between each other, being able to transfer assets across borders, right? Via subnets that, having validators only present in certain localities and being able to transfer assets between those subsets of different validators, right? So it's really powerful technology that's being built, right? And now you're actually starting to see folks that are using it. And so I had this final slide here, which was going to kind of go over some of the cool, I don't even know if you can see it because it's blacked out, but essentially that page is going to be all the different logos of cool subnets that are launching within the next couple of months to the next year or two, and ones that have been publicly announced at least. And so it's just a barrage of amazing titles, like you have names from the gaming side like Shrapnel, Gunzilla. You have major institutions like Intane Finance or Intane Markets. You got all the Spruce subnets that launched, the Evergreen subnets, right? So it was going to be a cool little visual, but unfortunately my visuals weren't working. So
well, no, I'm super excited. Thank you so much for that deep dive, man. That was great, Usman. I've got a bunch of follow-up questions, but also wanted to open it up to the Twitter space. If you guys have a question, like throw up a hand and we'll invite you up. Also YouTube as well. One question I have for you that I've kind of asked for in other gaming scenarios, which you brought up here for the BLS signature. What I get the general thesis around game assets and owning your game assets, but if those game assets never leave the game, what's the value of having it as an NFT? And maybe you can share with me like your thesis around what's driving the gaming asset marketplaces.
Yeah, 100%. And It's funny because I myself used to be a huge gamer, right? So I feel like I'm uniquely positioned to discuss this. But just give me one sec. I'm just gonna plug in my computer here. I apologize. It's gonna die on me.
Yeah, sure. Go ahead.
Okay, apologize for that. But yeah, gaming. So right now you're starting to see a lot of different major gaming studios actually really transition to the space. Initially, it was more so native Web3 games that were building within the space, starting to see lots of traction and start launching their own subnets. Right, you saw that happen with DeFi Kingdoms. You saw that happen with Grabada and Swimmer Network. You saw that happen with a lot of different games that were like, hey, we're native Web3 games. We're going to launch our own subnet because we're benefiting. We're seeing a lot of transactions. And then there was always this ideation, right, of, hey, blockchain can be used to own digital assets, right, whether that's in the music industry, whether that's in the art industry. And now it was always proliferated that, hey, now gaming is that next space where you can really take ownership of those assets. And to your point, if those assets never leave the gaming ecosystem, what's the point of assigning a certain value to them, right, or owning them? Well, two things there. You're starting to see assets on secondary marketplaces, right? Whether they're quote unquote NFT marketplaces or not, but in traditional games, starting to really skyrocket and process large amounts of transactional volume, right? So just the other day, and I saw this because of the Avalanche gaming team. Shout out to those guys because they're always on top of the gaming news. That there was a CS:GO skin. It was like a package where it was like a knife and a gun that was sold for a new record over like 200K, 300K, something like that. I don't know. It was some obscene amount, right? And so they're transferring these assets, right, which are essentially assets, on a secondary marketplace and transferring. I'm not too sure about the CS:GO mechanics, about how the actual assets are transferred. Like, hey, do I have to send you? Do you have to trust me to send you the gun after you pay me 200K? Right? Like, I'm not too sure exactly how that works, but I do know that these transactions are taking place off CS:GO's main platform. So you can imagine a similar mechanism where now at least we can assign certain values of these assets to individuals. These individuals can take these assets and be like, hey, I got this gun on shrapnel. I've gotten 300 kills with it, and now I want to put it up for auction on the shrapnel NFT marketplace, or whatever the case is. And now individuals could buy that gun from me and actually have a succinct way of doing so, and tangibly saying they own it too.
Understood. Got it. I know we have a couple more minutes here, but I'd love to get you back on and go through this again. I'm so bullish on the Evergreen subnet and Spruce because the mission of tokenizing assets is really to bring on commodities and stocks and those type of traditional financial tools, and those will only come in a place like Spruce. So that's super cool, especially as it relates to BLS signatures. When you guys think of those assets, how do you imagine them interplaying with other subnets across BLS?
Yeah, it's a great question. And I think once this is a great first batch of institutions who are really getting to play with this technology, and they're going to be able to see, okay, how do I want my assets stored? What assets do I want stored? Right? What do I see is working? What don't I see is working? Right? What way works best for me to run this blockchain? Right? And within that permission environment, there's a lot of nuances of how permissioned it can be, or what you can really do with all the different customizable aspects. So there's going to be a framework that's starting to be built out here, right? And then eventually you can imagine that once these institutions really start to see that projected benefit of utilizing a blockchain that they anticipate getting, many other institutions are going to come into play, right? And already are, right? Behind the scenes with the BD team. But I can imagine, and this is just my own personal opinion, right? I don't know anything that's going on behind the scenes on how these subnets work in terms of the actual institutional level stuff, right? That is, kept behind closed doors. But I can imagine that subnets, whether it's, let's say, for example, we have a JP Morgan subnet. I'm just throwing a name out there. There's no, right? I'm just giving you an institution, right? You have institution one, JP Morgan, right? And you have a Goldman Sachs subnet. Both of these subnets, store assets native to those different companies and institutions in their own permission private way, which no one knows what they're storing, right? Because they've said it that way. But I want to facilitate an asset transfer between JP Morgan to Goldman Sachs, subnet to subnet, right? Well, when that time comes and I want to facilitate the transfer, whether it's me as a user of those banks or it's the bank itself facilitating a larger transaction, they can go ahead and transfer that asset between different subnets, right? You could imagine that's going to create a whole new free-flowing financial world where now, let's say, the central bank of Japan, right? I'm just saying, for example, is able to communicate now with JP Morgan directly without having to go through any intermediaries and be able to transfer assets between each other and not have to. So it's a couple really far-fetched examples, but it kind of paints the picture of what is possible, and maybe not so far-fetched, right?
Right on. Okay, the other thing I wanted to cover before we end is what other cool VMs are you seeing? Like the leading question is, as Landslide connects into IBC, all of those IBC connections are going to need custom VMs. So the next VM that we're going to port over is the Polkadot VM, which Composable built a VM to run any Polkadot app on Avalanche, which is what they call the XSVM. So that's sort of next up through the Landslide roadmap. So that's a little alpha there. But I'd love to hear from you what else is being developed.
Yeah, for sure. It's a great question, and I would say just right off the top of my head, and these are something you already know some of these names. I would say the movement team is right up there. Move VM. I would say you guys are right up there. Porting over IBC and all the other alpha that you just dropped right there with XSVM. The Spark team, right, doing with C++ transpiler and all the different custom language VMs that they're kind of creating over there. It's kind of interesting stuff. Need to look a little bit more into it, but it looks really cool. But there are a couple other teams that are building some really interesting stuff. There's, like I mentioned, we have some incentivized programs that we're building out. One of them is based around a student team, which is really interested in the concept of KYC using zero knowledge proofs.
Yes.
And so that's a really cool use case that they're looking to build a virtual machine for potentially. And so that's a team I'm really excited for. Perfect use case, perfect,
What's the name of that team?
They don't really have a team yet. They're just ZKKYC. They're a student-led team.
Great.
They're actually we're a part of one of the accelerators that we're sponsoring. It's called Spawn. It's composed of a couple different universities across the country, and all these university students come together, all in Web3 and stuff like that. So they're all building projects on Avalanche this quarter, and they had the ZKKYC idea, and we're really pushing them to build a virtual machine. And I think they're going to go in that direction. So it's a really, really cool team, really cool environment. There's a couple others out there. There was just this weekend at Lion Hacks, which is Columbia's flagship hackathon. We had one of our DevRels, Martin, out there, and he kind of ran a workshop with like how to with relating to EVM precompiles, what is Avalanche, sort of like a high level overview. And we had one developer actually build a virtual machine in Rust, right, or something basic in Rust. And so I think that you're starting to see people actually push these out a little bit more frequently now. And I think that now, as we have more proof of concepts, as we have more iterations, I myself am playing around with the Hyper SDK, building a new implementation on top of the token VM. So adding a couple features to it, kind of showcasing what else it could do, just to kind of, showcase the different breadths of functionality that are present. That'll be cool. There's gonna be a lot more VMs being built soon. So
awesome,
exciting times.
Well, Usman, thank you so much for your time. I know you got to run. Thank you. We appreciate all of your insights and the deep dive. And I will have some of those links to the other talks you referenced in the show notes. But thank you so much. We look forward to connecting again soon.
Likewise, yeah. Thanks, Nathan. Best of luck with the rest of the summit, and you guys have been killing it. Looking forward to the rest of the talks.
Thanks. Appreciate it.